So this presentation or short video is going to look at an extension of the distributive law. It's called binomial expansion. So our learning goal today is to apply the distributive law to binomial expansion, which allows us to simplify equations and expressions. And it will allow us in future, particularly in grade 10, we spend a lot of time talking about quadratic functions, be able to manipulate and work with those functions. So the binomial expansion basically comes from the idea that there are two sets of brackets. Bi means two, nomial means numbers, so two groups of numbers is essentially what we're talking about. And they tend to look like this: something plus something in one bracket, something plus something in another bracket. So we're going to look at how we can manipulate those to expand and simplify the terms. So there are a number of techniques that we're going to look at, but both of them are just reminders. Think of it like a mnemonic or some other memory tool to help remember what steps to do. But as we did with the distributive law, it's really important that you understand that we're multiplying each term in one bracket by each term in the second bracket. There are a couple common mistakes that students make, which I'll talk about as we go. Remember to keep the sign with the coefficient at all times. So these are the three basic methods that can be used to help remember what's going on. The first method is called the FOIL method. It stands for first, outside, inside, last. And it's similar to the smiley face, just using letters instead of lines to help remember what it is. So with the FOIL method, it's the first term multiplied by the first term in each bracket. The outside terms, so in this case the x and the 2, then the inside brackets multiplied together, and then the last terms multiplied together. And you could think of it like a rainbow or a smiley face there in that case. Okay, so there are two methods. The third method is called the claw method. Same idea. It's where the numbers you're multiplying together form a little crab claw. So there's the top of the claw, there's the bottom of the claw. And same as the distributive law, this is just a tool to help you work out what you need to multiply together. As you get bigger brackets, these get messier, but it's the same process. X is multiplied by the x, then it's multiplied by the 2, then the 1 here is multiplied by the x, and then the 1 here is multiplied by the 2. So everything in that first bracket is multiplied by everything in the second bracket. So it's up to you which method you use. My preference is just to understand how it all works. So here's our first question. So I've got a series of questions there. Let's look at this one. So we can, if you like, multiply by x by the x, multiply the x by the 3, multiply the x, let's undo that one, multiply the 2 by the 3, multiply the 2 by the x there. So there's your little claw. Now, those lines aren't all that necessary. If you remember, it's just about multiplying that x by each of those terms, and that 2 by each of those terms. So let's look at how it looks. X times x is that one. X times 3 is that one. Positive 2 times this x, and then positive 2 times 3. Now what students tend to forget to do is do it by every term. So one of the biggest mistakes here is that they multiply the x by the x, first times the first, and then they do the last times the last. They forget the two middle steps. So that there is the biggest misconception students have when multiplying through those brackets. So the next line looks like this. X times x is x squared, 3 times x is 3x, 2 times x is 2x, plus 2 times 3 is 6. Then we group our like terms, which is always, or generally, those two middle terms. 3x's plus 2x's is 5x's. So let's look at the rainbow method. In this case, we have a nose, mouth, and then the two eyebrows. Okay, but the same process. The x times the x times the 3, then the 2 times the x, and then the 2 times the 3. So it's the same process, just using a different diagram to help remember what the steps are. Like I said, I just like to remember that it's this x times each of these things, and then this 2 times each of these things. We get exactly the same answer. Okay, And then the FOIL method. So FOIL, if you recall, is first. So multiply the first terms, then the outside terms, then the inside terms, then the last terms. So that's the upside down smiley face in this case. But once again, the same principle. It's just a clue to help you understand or remember which order to multiply things in, or to make sure you multiply all the things, but you get the same answer. So I'm not going to do all three of those methods again. We're just going to go through and look at each question individually and solve them one way. So in this particular case, I'm not going to draw any lines. You're more than welcome to though if you like. So in this case, we'll take the x and we multiply it by each of the terms inside the second bracket. So we get x times this x, then the x times the 3. That's this term here. Then we take the second term in the first bracket, -5, and we multiply it by the first term in this bracket. So it's -5 times x. And then this green -5 again times the second term in the second bracket, -5 times 3. Now because there's 2 terms in the first bracket, 2 in the second, you get 4 total terms. So we simplify that, x times x, x squared, x times 3 is 3x, -5 times x is take 5x, or -5x, -5 times 3 is -15. Group the middle term, so that's 3x, take 5x is -2x. Okay, next example. Now I've got coefficients in both parts. So in this case, same as before, 2x times each of these terms, and then the 2 times each of these terms. So 2x times 2x is the first bit, that's that one, multiply by that one. Then 2x times the 3, the second term in the second bracket. And then we do the 2 here, 2 times this one, plus 2 times this one. Simplify, 2 times 2 is 4, x squared. 2x times 3, so 3 times 2 is 6, x. 2 times 2 is 4, x. 2 times 3 is 6. Group the like terms in the middle there, and we get 4x squared plus 10x plus 6. Okay, now I've got some negatives in both parts. Remember, the negative stays with the coefficient. But same principle, 2x times the -3x, then the 2x times the 4, the -2 in the first bracket times the -3x, and then -2 times 4. Here is that 2x times -3x, 2x times 4, -2 times the -3x, and then -2 times 4. So this here, 2 times -3 is -6x squared, 2 times 4 is 8 with the x, -2 times -3 is +6x, -2 times 4 is -8. Group the middle term, that's 14x's. -6x squared plus 14x, take 8. Here's another one where the order's switched around. So the process doesn't matter. You don't need the pronumeral as the front. Okay, it can be in either order, and usually we write it with the negatives or the takes at the end. It's just less writing. Otherwise we'd have to write -2x plus 7. So it's the same process. It's 7 times the 4x is our first multiplication, then 7 times the second term, 7 times 1. Then we take the -2x here, remembering the negative stays with the 2. So it's -2x times the first thing, which is 4x, plus -2x times the second thing, which is 1. So 7 times 4x is 28x, 7 times 1 is 7, -2 times 4 is -8, x times x is x squared. -2 times 1 is -2, x. There are like terms of the x's here. So it's 28, take 2 x's, is 26 x's. And generally we write them in order of power. So x squared first, then x, then the constant. -8x squared comes down. We've simplified the like term here. 28 x's, take 2 x's is 26, and then plus 7. Alright, this is a pure algebraic one, so let's look at what that looks like. Same process. 3a times 2a, 3a times 2b, -4b times 2a, and -4b times 2b. So 3 2's are 6, a times a is a squared, 3 times 2 is 6, a times b is ab, -4 times 2 is -8, b b times a can be written as ab. Remember, we write them in alphabetic order. And negative 4 times 2 is negative 8. b times b is b squared. Look for like terms. That's these two in the middle. 6ab take 8ab is negative 2ab. So we end up with this. 6a squared take 2ab take 8b squared. So that's a variety of different binomial expansions to allow you to look at different components and simplify different expressions.